Are you fucking?
I posted the link for our notebook in the chat. You can click on that. Make sure you are working on the warm up, finding our answer to the warm up in our notebook. Type it into the chat. Do not hit enter until I say so. I'll give you guys about 2 minutes. Alright, how many of us have an answer? 2 people? 2 people have an answer? Jeez. You guys gotta wake up. You guys gotta go outside, go for a run. I'll give you another 30 seconds. I'll give you a hint. The answer might be on the page for rotation rules. Alright, let's hit enter on our answer, please. Good. That is our rule. Negative y x. Alright. Let's look at transforming a figure onto itself. That is what we will be starting today. Transforming a figure onto itself. What does that mean? Well, taking a figure, applying a transformation to the figure, and the image looks identical to the pre-image. Alright. Basically means once you apply a transformation to an object, after you apply the transformation, the image that you're looking at looks like it hasn't changed at all. Okay. So for example, if I'm looking at this marker right here, right? You guys see how the marker it has the blue cap on this side, right? If I apply a 360-degree rotation to this marker, like this, 360 degrees, then it ends up in the same exact spot, right? So that is a transformation of this figure onto itself, meaning I applied a transformation, but it remained the same. How to determine line symmetry, because we can do this in two ways. We can do this with line symmetry and rotational symmetry. So how to determine line symmetry? If you fold the figure along that line, it will look exactly the same. It will be the same. It will be the same size, same shape, and in the same position. How to determine rotational symmetry? If the shape is a regular polygon, you can simply divide 360 degrees by the number of sides or angles. Now, let me ask you guys this. What is a regular polygon? Type it into the chat, please. Take your best guess if you don't know. I'll give you guys 30 seconds. Take your best guess if you don't know. First thing that comes to mind. Type it into the regular polygon. Don't Google it. Take your best guess. Type it into the chat. You do not have to wait for me to tell you to hit enter. What is a regular polygon? We got a shape. A four-sided shape. A five-sided shape. A pentagon is an example. Very true. Five-sided shape. A four-sided shape is also an example, though. A square is one. Yes, it is. I got 1, 2, 3, 4, 5, 6. 6 answers out of 16 students. A shape with straight sides. Okay. I got 8 answers. 10 more seconds. Again, guys, this goes towards your participation. A circle is not polygon. Hexagon. That's another example. A shape, 5 sides. Okay. A shape with 5 slides. That's a different one. Sides, I know. Alright. Now utilize the ever so useful Google. Google. What is a regular polygon? Quick, 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 quick. Use the Googles, quick. two-dimensional shape when all angles are equal. We gotta speed up our Googling process, guys. The shape with equal angles and enclose the shape. What is taking so long?
That's really sus.
Any shape made up of straight lines without curves, all equal angles. I'm starting to feel like nobody actually Googled this. Yeah, no. What's up, Michael? Jesus. You guys gotta wake up. This is bad. I'm gonna go with you. Alright. A regular polygon, since everyone's too lazy to look up the answer themselves, a regular polygon has all equal sides and all equal angles. Alright. That's it. Ways to transform this rectangle ABCD onto itself. When we have a rectangle, such as a piece of paper, if you reflect it across its line symmetry, you can go straight up and down vertical. You can go straight across horizontal. So if I reflect it across its line symmetry, I can reflect it this way, and it will still look exactly the same. Right? Does everybody see that? It looks exactly the same. Then we have this here. When we rotate it this way, it still looks exactly the same. Okay. So that is like if I reflect it across line M, which is straight up and down, and if I reflect it across line N, which is straight across. 180-degree rotation. If I rotated this, notice my how to determine rotational symmetry says if the shape is a regular polygon, you can simply divide 360 degrees by the number of sides or angles. Okay, so 360 degrees divided by 4 is 90. So let me ask you guys this question: is a rectangle a regular polygon? Type it into the chat. All equal sides and all equal angles.
So a regular polygon has all equal sides?
That is the definition for a regular polygon. All equal sides, all equal angles. Alright, is a square a regular polygon? Okay, is a parallelogram a regular polygon? Parallelogram. A parallelogram. It's fun to say. Parallelogram. Stumped. I got a no, I got a yes. I don't know who Jesse is. I don't know, maybe, yes. IDK and maybe are both not acceptable solutions. A parallelogram is not a regular polygon. Why? Because the sides are not equal. The angles are not equal, which completely defies what a regular polygon is. Regular polygon says all sides and all angles must be equal. Here's a regular polygon example right here. Parallelogram, I should say. Here's a parallelogram right here. These angles are obtuse. These angles are acute. Right? Those two angles are not the same. What about a octagon? Is an octagon a regular polygon? Sure. What about a trapezoid? Once again, here's what a trapezoid looks like. What about an isosceles triangle? Which one's that? Yeah, there are two types of trapezoids. There's an isosceles trapezoid and a regular trapezoid. What about the rhombus? We'll get there. The isosceles triangle has two equal sides and two equal angles. So no. Yeah. That third side, well, the answer is it depends. Because the third side is also equal. That isosceles triangle can be an equilateral triangle. And in that case, it'll be yes. But if that third side is not, then it is not. This is where Owen's answer of maybe is an acceptable solution. Yeah, what about a rhombus? Sammy says maybe. What about a rhombus? A rhombus is like a great value square. It's like the Walmart version of a square. I think yes. Yeah. A rhombus is like a square and a parallelogram had a kid. So a rhombus has all equal sides.
Jesus.
Angles are only opposite equal, meaning on different sides of the corners, like this corner and this corner are equal, this corner and this corner are equal, but they're all not equal. Only pairs are equal. Cool. The only four-sided figure that we can agree was a regular polygon was a square. Every other four-sided figure was not. Right? Trapezoid, parallelogram, rectangle, rhombus, all, and they were not regular polygons. A square is the only regular polygon that is a quadrilateral. And we'll talk about that when we get to that quadrilateral section. But I just wanted to introduce you guys to it because I don't want anyone thinking that they can use this regular polygon rule on a rectangle or a trapezoid. You can only use it for a square, triangle, pentagon, hexagon, septagon, octagon, nonagon, decagon. Alright, with that being said, if I try to use this rule this 360 degrees divided by 4, 90 degrees, right? So if I have this rectangle and I rotate it 90 degrees, you guys see how the shape looks completely different now? Here is short and fat. Here it's tall and skinny, right? 90-degree rotation, short and fat to tall and skinny. But with an 180-degree rotation, still short and fat. Okay? And with a 360-degree rotation, same thing, right? Go all the way around. Still looks exactly the same. Right? So those are 4 ways you can transform a rectangle onto itself. Here's like our cheat sheet right here. This is our cheat sheet. At least to start off. Our cheat sheet to start off. We got line symmetry, a reflection across the figure that carries the figure onto itself, which we just talked about, and we have rotational symmetry. We got line symmetry for a rectangle is only 2, right? I can only fold this rectangle across like this or sideways like this. That's the only way I can fold it. I can't fold it diagonal because then I have this weird thing right here where it's like extra space, right? It doesn't work for a rectangle. But for a square, I can fold it diagonal like a napkin, right? You fold it completely in half and you'll have yourself like a triangle. You can do that. Notice for the rotational symmetry for a rectangle, it's only 2. It's only 180 degrees, and it's only. But for a square, because it is a regular polygon, you have 4 degrees of rotational symmetry because it has 4 angles. So in other words, every time you turn it to the new angle, you'll see that you have the same exact figure. Parallelogram, same concept as rectangle. It's just 180 degrees to 60, and there's no way you can fold a parallelogram to be symmetrical. Trapezoid, same thing, no lines of symmetry, and you can only turn it one way. Now let's look at the regular pentagon. We use this rule of 360 divided by number of sides to get us our minimum rotational symmetry. So for a regular pentagon, we got 360 divided by 5. That gives us 72. Now, what if I want to find the next rotational symmetry? Well, I would just take 72 and add it to 72. So I'll do 72 plus 72, and that will give me 144. And I'll do that again to find the next one. Plus 72, 216. Plus 72 to get to the next one. Plus 72 until I get to 360. Once I get to 360, I have my total number. And usually it's just going to be the number of sides. Okay. Do that same concept for 6-sided figure. 360 divided by 6 is 60. Okay, well, what's the next one? I add 60 to it. What's the next one? Add 60 to that. What's the next one? Add 60 to that. All right, and you keep going up until you get to 360. Okay. So, how do I calculate the degrees of rotational symmetry for other shapes? We just talked about that, right? Divide 360 by number of sides. So, how many degrees of rotational symmetry does a regular polygon have? A regular octagon have, I'm sorry. So, if a regular pentagon had 5, right? It had 5 total numbers. 5 total numbers of rotational symmetry. A hexagon had 6. How many should an octagon have? Type it into the chat. How many degrees of rotational symmetry should an octagon have? Pentagon had 5. Hexagon had 8.